Welcome to Cherry Hill Tuition, where incredible results are achieved. In this mathematics tutorial, I will cover some of the excellent processes used by Cherry Hill to achieve the highest grades. Let's get started. Before we get started with the carefully selected questions, let's just quickly go over the basics of fractions. Okay, so when we are adding fractions, what we need to do is try and get both denominators to be the same number. Once this is done, we can then add the numerators and reach a final answer. So let's go through this now. We need to find the lowest common multiple for 2 and 4. Hopefully you will know that the lowest common multiple for 2 and 4 is 4. So we need to convert both of these fractions into a fraction which has the denominator of a 4. So let's start with the first one. Now, in order to turn the 2 into a 4, we need to multiply this by 2. And an important rule that you need to remember is whatever you do to the bottom of a fraction, you have to do to the top of the fraction. So we multiply the top by 2 as well. Okay, this leaves us with 2 over 4 plus, now with the second fraction, the denominator is already a 4. So we do not need to change this fraction. We end up with 3 over 4. Now that the denominators are the same, we can go ahead and add the numerators. So 2 plus 3 gives us 7, and the denominator always stays the same, and that's your answer. Okay? Now, when we're taking away fractions, we follow the same concept. So we need the denominators to be the same number. Because the denominators are not the same, we will need to do some converting. We need to find the lowest common multiple of 5 and 3, and hopefully you will see that the lowest common multiple for 5 and 3 is 15. So we need to convert both of these fractions into into fractions that have denominators that are 15. So if we start with the first one, we need to multiply this 5 by 3 in order to get a denominator of 15. And remember, we do the same to the top. This leaves us with 3 multiplied by 3, which is 9 over 15 minus, now the second fraction, we need to multiply the denominator by 5 in order to get 15, and we do the same to the top. This leaves us with 10 over 15. Now that the denominators are the same, we can go ahead and take the numerators away. So 9 minus 10 is minus 1 all over 15. Okay, so the denominator stays the same. So for adding and taking away fractions, the concept is it's basically the same. The only difference is whether you're adding or taking away, okay? Now let's move on to multiplying fractions. When we're multiplying fractions, so let's just change the denominator into 5. When we're multiplying fractions, it is very simple. So all we need to do is multiply the numerators together in order to get our new numerator. So 4 multiplied by 2 is 8. And then we need to multiply our denominator. So 3 multiplied by 5 is 15, and that is our denominator. And this is all you need to do to get your answer. Okay, so it's very, very straightforward. Now, moving on to dividing fractions, this is when it gets a little bit more complicated. It's not very complicated, it just involves an extra step. So let's say we have 2/3 divided by a half. So there are 2 steps. The first step is changing the division sign into a multiplication sign, and then flipping the second fraction. So 1 over 2 becomes 2 over 1. the first fraction always stays the same, and then you just go ahead and multiply as normal. This gives you 4/3, and that's your answer. Okay? So let's just try one more division example to wrap our heads around it. Okay, so the first step is to keep the first fraction the same, so 6/5. We then change the division sign into a multiplication sign, and then the second fraction we flip and we turn it into 3/4. And then we just go ahead and multiply. So 6 multiplied by 3 is 18. 5 multiplied by 4 is 20. We can divide both sides by 2 in order to simplify the fraction, leaving us with 9/10. Okay? And that's all you need to do. So hopefully those concepts made sense. Now let's move on to a little bit more advanced fractions like algebraic fractions. Okay, so we have 1/a+3 plus t over b minus 4. Now, when it comes to adding algebraic fractions, we can't really find a lowest common multiple because we're dealing with letters here. So what you need to do is multiply both denominators together, which gives you a+3 brackets b minus 4 brackets. And this is the denominator that you need. Okay? So let's rewrite this question here. So 1/a+3 plus 1/b minus 4. Okay, so we need to now convert both fractions into fractions that have this denominator here. Now with the first fraction, we need to multiply the denominator by b minus 4. And as explained previously, we need to do the same to the top, leaving us with multiplied by b minus 4 at the top. The second fraction, we need to multiply by a+3, and we do the same to the top. Now this leaves us with 1 multiplied by b minus 4 over a+3 b minus 4 plus 1 multiplied by a+3, sorry, this should be a t. Here. So t multiplied by a+3 all over b minus 4 multiplied by a+3, okay? So now you can see that our denominators are the same. So we can now combine the numerators. So let's go ahead and do this now. So 1 multiplied by b is b. 1 multiplied by minus 4 is minus 4. And then we have plus t multiplied by a, which is ta, and t multiplied by +3, which is 3t, all over the denominator a+3, b minus 4. Okay? So hopefully you can see that there is no way that we can simplify this answer because we have no like terms. So this is your final answer. Okay, so let me rewrite this. So our answer is b minus 4 plus ta plus 3t all over a+3 b minus 4. Okay, so hopefully that made sense. Now pause this video and try this question on your own. See if you get the same answer. Okay, so now we have another algebraic fraction that we need to subtract. We have nk over f plus 1 minus d plus 9 over d plus a. So like we did in the previous question, we need to multiply f plus 1 with d plus a to get our desired denominator. So just as a disclaimer, you may have noticed that we've jumped from question 1 to question 9. So this is simply because the question numbers are specific to the Cherry Hill material, but do not worry if you do not have access to this, as I will still cover the concepts in both. Okay, so like I said, we have our desired denominator, and we need to now turn both fractions into fractions that have this denominator. So let's get started. Okay, so we need to multiply f plus 1 by d plus a in order to get that desired denominator. And we do the same to the top. And we need to multiply d plus a by f plus 1. And we do the same to the top. Okay, so this leaves us with nk multiplied by d plus a minus d plus 9 multiplied by f plus 1 all over the same denominator, which is d plus a multiplied by f plus 1. Okay, so now the last step is to expand the numerator and reach a final answer. So nk multiplied by d gives us nkd. Nk multiplied by a gives us nka. And then we have minus d multiplied by f, which is df. D multiplied by 1, which is d. And then we have 9 multiplied by f, which is 9f. And we have 9 multiplied by 1, which is 9. Okay, and that's all over d plus a multiplied by d plus 9. Sorry, d plus a multiplied by f plus 1. Okay, so now we can expand the brackets in the numerator again. We end up with nkd plus nka. Now we have a minus sign multiplied by df, which is minus df, minus sign multiplied by d, which is minus d, a minus sign multiplied by 9f, which is minus 9f, and a minus sign multiplied by 9, which is 9. This is all over d plus a multiplied by f plus 1. Okay, so we don't have any like terms in the numerator, so we can just leave it as it is, and this is our final answer. Okay, so this one required a few more algebraic steps, but we got there at the end. So again, pause this video and try it on your own and check if you get the right answer. Okay, so question 16, we have 1 plus b over c is equal to f over 3, and we need to make f the subject. Okay, so what we need to do is simplify these fractions and then somehow make f the subject. So we have 1 over 1, that's what we can treat this as, plus b over c is equal to f over 3. So let's simplify the left-hand side of the equation first. So like I said, when we have algebraic fractions, we can just multiply the denominators to get our desired denominator. So we have c. So we need to convert these fractions into fractions that both have the denominator of c. So we can multiply the first fraction by c. The second fraction already has a denominator of c, so we don't need to make any changes. This leaves us with 1 over c plus, so 1 multiplied by c, which is c. So c over c plus b over c is equal to f over 3. And now that the denominators are the same, we can change this into c plus b over c is equal to f over 3. Okay? So we need f on its own. This is what it means by making f the subject. What you need to ask yourself is what's stopping the f from being on its own? Hopefully you will see that it's the divide by 3 that is stopping the f from being on its own. Divide by 3. So in order to eliminate this divide by 3, we need to multiply by 3 because this is the opposite. And whatever we do to one side of the equation, we have to do to the other side of the equation as well. This leaves us with 3 multiplied by c plus b over 3 over c is equal to f over 3 multiplied by 3. Now on the left-hand side of the equation, we are left with 3 multiplied by c plus b over c. And on the right-hand side, we are left with just f because the multiply by 3 and the divide by 3 cancel out. And that is your final answer. So f is equal to 3 over c multiplied by c plus b. Okay? So hopefully this question made sense. Again, pause this video and try this question on your own. Okay, so now we have 1 over 4e plus 1 over c, which gives us k over 3, and we need to make c the subject. Now, because we're making c the subject, we need c to be a numerator, not a denominator. And because currently c is being divided, we need to multiply by c on both sides in order to bring it to the top. So we end up with 1 over 4e multiplied by c plus 1 over c multiplied by c, and this is equal to k over 3 multiplied by c. Now, 1 multiplied by c is c, which is over 4e, plus 1 multiplied by c, which is c over c, and this is equal to k multiplied by c, which is kc over 3. Okay? So we can simplify this because c over c, something divided by itself gives us 1. So we can change this into a 1. Okay? Now, the next step is to make sure that everything that contains the letter that we are making the subject, it all needs to be on one side of the equation. So what we can do is take this onto the right-hand side. Now, because we're adding right now, we need to eliminate this and bring it to the right-hand side. So we minus both sides by c over 4e. Okay, now this leaves us with c over 4e plus 1 minus c over 4e is equal to kc over 3 minus c over 4e. Now on the left-hand side, the c over 4e and the minus c over 4e cancel out, leaving us with just 1. And on the right-hand side, we have kc over 3 minus c over 4e. Okay? So we now have an algebraic fraction on the right-hand side. We need to simplify this in order to get closer to our answer. Okay, so let's move this over here so we have some more working out space. So 1 is equal to kc over 3 minus c over 4e. So like I mentioned previously, we need to multiply the denominators to give us our desired denominator, which is 12e. And we need to now convert these fractions into fractions that have the same denominator. For the first one, we can multiply this by 4e, and we do the same to the top. And then for the second one, we can multiply this by 3, and we do the same to the top. This leaves us with 1 is equal to 4c multiplied by kc minus 3 multiplied by c, which is 3c, all over 3 multiplied by 4e, which gives us 12e. Okay? So we have 1 is equal to 4c multiplied by kc is 4kc squared minus 3c all over 12e. Now we need to multiply both sides by 12e in order to get rid of the 12e on the right-hand side, because we need to try and make c on its own. This leaves us with 1 multiplied by 12e is equal to 4kc squared minus 3c all over 12e multiplied by 12e. On the left-hand side, we have 1 multiplied by 12e, which is just 12e. On the right-hand side, the multiplied by 12e and divide by 12e cancel out, leaving us with 4kc squared minus 3c. Okay? Okay, so question 18, we have 3g over 4 plus c over g is equal to f over b, and we need to make b the subject. So the first step is to multiply everything by b, and the reason we do this is because right now b is a denominator, and we need b to be at the top in order to make b the subject. So we multiply everything by b on both sides of the equation. This leaves us with 3g over 4 multiplied by b plus c over g multiplied by b is equal to f over b multiplied by b. Now, 3g multiplied by b is 3gb, and that's over 4, plus c multiplied by b, which is cb, over g, and this is equal to f multiplied by b divided by g. So the multiplied by b and divide by b cancel out, leaving us with just f. Okay? So we now need to simplify this fraction on the left-hand side. And with algebraic fractions, what we need to do is multiply the two denominators, which gives us 4g. And now we need to convert these fractions into denominators with 4g. So the way we can do this is we can multiply 4 by g, and we do the same to the top, giving us 3g squared b over 4g, and then we have a plus. For the second fraction, we can multiply this by 4 and the top by 4, leaving us with 4cb over 4g, and this is equal to f. Okay, so now that the denominators are the same, we can combine this into 3g squared b plus 4cb over 4g is equal to f. So let's move this here so we have some more working out space. So we need to make b on its own. So we need to think to ourselves, what is stopping the b from being on its own? We currently have this fraction. We have a denominator that we do not want. So we can multiply by this denominator in order to eliminate this on the right-hand side. This leaves us with 4 multiplied by, so let's get a black pen. Four g multiplied by f is equal to 3g squared b plus 4cb over 4g multiplied by 4g. On the left-hand side, we are left with 4gf, and on the right-hand side, the multiply by 4g and the divide by 4g both cancel out, leaving us with 3g squared b plus 4cb. Now it's quite simple. What we need to do is we need the b on its own. And we have b in this term and this term, in all the terms on the right-hand side. So we can factorize this. We can bring the b out inside the brackets. In order to get 3g squared b, we need a 3g squared here, and then a plus 4c. And now this is the only thing stopping the b from being on its own. So right now it is multiplying by the b. In order to eliminate this, we need to divide by this. And we do this on both sides of the equation. Okay, and that leaves us with 4gf over 3g squared plus 4c is equal to b 3g squared plus 4c all over 3g squared plus 4cb. So there should be a b here, b. Okay, now on the right-hand side, both of these terms cancel out, which means we have made b the subject. We are only left with the b on the right-hand side. So b is equal to 4gf all over 3g squared plus 4cb. Okay? So hopefully that made sense. Again, what I need you to do is pause this video and try this question on your own again and see if you get the correct answer. Thank you for tuning in. Remember, practice makes perfect. Never give up. I will see you in the next tutorial.